get started. Thank you, everyone. I think we are almost towards the end of the 2 days. My name is Mihir Acharya. I'm from MathWorks. I'm a product manager for autonomous navigation, UAV Toolbox in the robotics team at MathWorks. And with me, I have my colleague, Ronal George. He's an application engineer. We both will be presenting about simulating and deploying UAV applications, simulation in the loop and hardware in the loop workflows using MATLAB and Simulink with PX4. So this is the agenda of our talk. We'll briefly go over the introduction. We'll go over the 3 different types of simulation workflows with PX4. We'll introduce scenario simulation that you can use with MATLAB and Simulink. And then we'll close out with some summary and resources. So I wanted to paint a big picture in the beginning. This is something like a city scene, and thinking about drones, I really get fascinated about thinking to have a drone being flown through the city scene, maybe for different applications like package delivery or medical responses, and it will just make things really fast. But how do we get there is the question. And we also heard from Lawrence in his talk that we're really not there yet. And a lot of these type of applications are really highly safety critical. So what do we do to make them safe? And that's what this talk is about, to have simulation being done before deploying these drones to have safe operations. So before going there, there are multiple steps we are going to show you. And at the end, what we want to do is validate and deploy these drones. But before that, you have to design and simulate these, including scenario simulation, including various models, algorithm design. And another piece of the puzzle is planning the mission from where you get those information that you use to design your algorithm and simulate. Now, there are these 3 building blocks that we would like to show you today with different pieces in MATLAB and Simulink that you can use. So under the validation and deploy, we'll show you how you can use PX4 and deploy flight controllers on PX4 from Simulink, and how you can use different algorithms and models in Simulink to design your algorithms and simulate your scenarios, and how you can integrate with ground control station like QGC within MATLAB to provide your mission waypoints. So all these together build our model that we use inside Simulink. And I hope most of you are familiar with Simulink. It is a graphical model-based platform where you can design your models, and you can also deploy those models as a C++ code. So what we'll show you how to design your flight controller in Simulink and have your plant model in Simulink, and then you can deploy further it on PX4. So when you have your flight controller running in Simulink on your host PC, we call it model in the loop simulation. And when you deploy it as a C++ executable, we call it software in the loop. And when we have the PX4, we have the Pixhawk autopilot in the loop, and the flight controller from Simulink deployed on it, we call it hardware in the loop. So these are the 3 different workflows that we'll be talking about. And then while we are doing this, we also want to visualize how our flights are looking like, and for which we have Unreal integration where we launch Unreal within Simulink, and we visualize different flight scenarios while the hardware in the loop is running. And you can also deploy algorithms on Jetson right from Simulink, so you can prototype your algorithms, and when they're ready, you can deploy it on Jetson and have your autonomy running on NVIDIA Jetson board. So before we jump into all this, brief background. So we have a product called UAV Toolbox that was launched in 2020. It is an add-on product along with multiple other add-on products that we sell along with MATLAB and Simulink. And you might be familiar with MATLAB. It's a programming language to analyze data, develop algorithms, create models. And I already talked about Simulink a little bit. And a little bit about MathWorks. millions of users there. We have grown as a company, more than 5,000 employees now. We are a $1 billion revenue recently, and we have multiple offices, and our headquarters is in Natick near Boston. And about our robotics group, so we support various different kinds of robotics applications, including manipulators, ground robots, autonomous driving, UAVs, marine robots, and what's our focus today is for the UAV toolbox here. And going into why Simulink and what's the benefit of working with MATLAB and Simulink for PX4. So what we are really promoting here is the thought of verification and validation, which is we call as a V model. And we start with modeling and simulation here with executable design requirements. And then we go into the code generation phase. Once our models are in place, we generate a C++ code. And finally, we can test and verify it in the same environment. So this model really helps our customers with a full end-to-end workflow. And we have lots of success stories around that I'll go into a little bit. And why you would like to build your plant model in Simulink is another thing I want to mention here. And we have multiple phases how you can build your plant model in Simulink, starting from low fidelity. We provide blocks in Simulink that you can use. And you can go to high fidelity where you can have more photorealistic simulation models. And this really lets you to go from really proof of concept stage to a more advanced stage in the same environment. So we worked with Yamaha recently, and that was one of our success story who used this workflow, the V model, and they used it for a large-scale drone, and they were using Pixhawk autopilot, and they deployed algorithms that were designed in Simulink on their drone. So this was something that we were able to test our tools along with Yamaha using model-based design. So with that, I would like to hand over to Ronal, and Ronal will talk more about the 3 types of simulation that you can do with Pixhawk.
Awesome. Hey, everyone. Thanks, Mihir. As Mihir mentioned, my name is Ronal. I'm an application engineer, mainly support robotics and autonomous systems. So Pixhawk. I'm pretty sure most people here know what the Pixhawk is. If you haven't heard of it, this is the Pixhawk 4. That's the one we used for the demo, so that's what I wanted to showcase. Simulink and MATLAB actually just don't work with the Pixhawk. We can work with anything that runs the PX4 firmware. So if you want to just use your own stock and use the FMU that comes from the PX4, you can use those. You don't have to go with the Pixhawk itself. So going further, let's take a look at what we provide out of the box from Simulink. So here you can see that there's a ton of blocks that we provide, both for communication, and we provide ways to read directly from the Pixhawk itself. So let me go into the architecture so you get a little better idea of how it's supported. So we give you ways to read directly from the UART microbus, from the message bus itself. There are blocks that let you read directly from any of the sensors. You can read RC input. So these will be blocks that you can build your actual control module. So when you build this out in Simulink, you can start taking these blocks, and those can be the way you either read from microorb messages or actually just read directly from the sensors hub. When we talk about deploying to the Pixhawk, what we actually do is we disable both the position controller and the attitude and the rate controllers, and we deploy our own app. I'm not sure if you're familiar with how you can push a custom app to the PX4 firmware. There's actually good documentation on it, but what we do is we take off both these controllers, and then we directly deploy a Simulink app that then can read the current state and then push in your own specific controller. Maybe you have a different mixer, or your drone's not just a standard chord, it has tilt and pitch for each of its arms. So the control scheme's not just going to be the standard position rate controller. So yeah, that's what I'm going to go over today. Any questions starting already before I jump into this? All right, let's go further. So as Mihir mentioned, this is the larger workflow. I'm going to start with actually going through model in the loop. So this is where you have everything in Simulink itself. You haven't generated any code yet. You don't have the autopilot attached to your computer. Then we'll go into software in the loop. This is where we actually generate a C++ executable. We communicate via UDP to the executable. It's running on your host machine itself. But then that's verifying that your model as C++ code does what you expect it to do. And then finally, we can take that generated code and deploy it directly onto the Pixhawk. It's going to be in hardware in the loop, so all the sensors will be disabled, but we'll simulate the sensors. But you can guarantee that your code's running. The flight controller is actually running it as a processor on the PX4 itself, on the Pixhawk itself. Cool. So this is the first piece where we're not connected to a ground station yet. We're just going to go ahead and send in simulated waypoints. So you can put in an attitude or trajectory, and then you can push that to your flight controller. There's two models that's built in Simulink. One is your actual flight controller, and the other one's the plant model. The plant model is based out of just first principles. We look at standard physics and see how, what's the expected aerodynamic forces on this drone? What's the masses of it? What's the inertias of that drone? Right, so here's an example. This is available for you to go take a trial, and if you click on that link, we'll share the slides. We have some resources in the end. But let me show you how this actually works. So what you see here is the entire simulation is actually running in Simulink. You can see there's 3 different blocks. Simulink lets you build some really nice UI dashboard scopes where you can change the altitude, you can change what kind of guidance you're in. Are you doing an orbit, or you're just hovering? So let's break down the model a little more. You can see I have commands coming in from one subsystem. This is just what the dashboard on the bottom actually just changed the inputs there. Then we have our actual controller. This controller has a feedback from the plant itself, and then the final thing is our plant. Now you would wonder, what is the protocol that we're using to communicate between the plant and the actual flight controller? We're using MAVLink, so these are routing MAVLink messages around. Simulink understands MAVLink and can talk MAVLink. The first block that you see here actually converts that MAVLink message into a micro-orb message, because that's what our flight controller will need, and that's what we want to deploy into it. It's a cascaded flight controller, cascaded PID. You can see we have both a position and attitude controller and a rate controller. And then finally, we have to convert those micro-orb messages to MAVLink messages so we can send it back to our plant. Here you can see inside we have a MAVLink read block. That's where we actually go through and see what these MAVLink messages contain. Here we have multiple blocks. One actually is for the plant itself. We built our plant using a 6-DOF ridge body mass. You have forces and moments coming in, and then we send outputs directly to the actuators. The second piece here is we actually have our sensor model. So here you have IMUs, GPSs. Because we're going to do hardware in the loop, these are going to be disabled, so we simulate these. And you can see we actually create a MAVLink message that we can send back to our plant. So that's the 3 pieces when you're doing everything in simulation. And that's the first step. And just showing you what we looked at again. When I go and push these commands, those are the commands that are getting sent into my actual flight controller. And the response you can see as an animation. Great. So once we've already tested this, we like the response that we get from our drone. What we want to do, or our simulated drone, what we want to do is go ahead and generate some C code and see what our performance looks like at this stage. Again, we put out an example for this. So if you want to try it out yourself, there's an example available. I'm going to walk you through this. So the difference here, now you'll see that I've actually split my single model into 2 models. The one on top is the actual flight controller. The one on the bottom is my plant. Everything inside it stays exactly the same. The model on the top that you can see is running fairly fast. That's not actually running in Simulink. You still get to use Simulink as a debug window if you want. It runs as generated code. And this is just me verifying. I get the same response. It is running in lockstep, so you will see a slight slower performance because we're we have an app in the background that we're communicating via UDP. So if you see that we have any delays, we're going to slow down our plant to make sure we're running in lockstep. Right, so this is actually going into the model itself. I'm not going to explain this further. It's the exact same one we saw a second ago. I just split it up so that I can generate C++ code for this. On the other side is my plant and the sensors. There's a UDP interface that I've added now because of the generated code, and that's how we're going to communicate. And of course, it still sends out Mavlink messages via UDP. So all I have to do is go ahead and select my board as host target, and then I can go and hit monitor and tune. You can also run it as built, but monitor and tune actually lets you still have access to the Simulink blocks. So if you want to go ahead and look at what some of the messages are, or you want to actually provide input commands from Simulink, which is going to go into the C++ code and modify the parameters there, that's really easy to do. So it's going to launch a black screen, but what it's doing is launching the actual C++ code. It's running it in the background, and once that's ready, I can go ahead and actually start my plant. Of course, with the plant, I also have the same animation that I used the first time, so you can actually go into it and launch out the animation. You'll see here, as I launch the animation, and this is a very quick, low-fidelity animation that, when you're starting out, you don't really need a super detailed photorealistic scene. You just want something that shows you how your drone's responding when you provide certain, commands. Right, so this is running as C++. Just to reiterate, the flight controller we've generated code from it, and it's running as a secondary app in the background. But you still get to use Simulink as your debug or your input window, where you can either look at what the commands are or modify some of the commands to the flight controller itself. Great, so we've taken something that was completely in Simulink, and then we've generated C++ code. The next piece is now actually pushing this code onto the Pixhawk itself. So we work with the PX4 firmware. Any board that has the PX4 FMU, we can go ahead and deploy to it. As I mentioned, we actually disable 2 of the controllers or the modules and put our own app into it. So here you can see this is actually running in hardware in the loop. I have QGC now connected, so I'm taking commands from QGC, which is going to give me a waypoint mission that I deploy onto my drone, and then I can run the mission. You can see on the left bottom that's the model. It's slightly different because we actually made this slightly bigger to add additional autonomous capabilities to it, but the actual controller is very similar to what we saw before. On the right-hand side, you will see that that's my plant. The really nice part about doing hardware in the loop with Simulink is I actually get to see what my states of my plant are. I can go into the sensors and start reading what the sensors do. So here I'm just kind of opening it up to see what the model looks like. This is where we have an additional navigation scheme. But of course, the flight controller is going to send, that's your mixer, and it's going to send out outputs to the PWM drivers. And for me to actually generate code, I go ahead and select what board I want to generate code to. If you're not using one of the boards that's listed, you can say it's not seen here, and then actually just point it to the FMU that you're using. Of course, if you want to boot to the firmware, you have to actually restart the board. That's when I have to unplug it. It's going to tell me, OK, once you're ready, hit OK and plug it back. And then now Simulink's going to deploy it to my actual board. Now, because I'm running hardware in the loop, I have disabled all the auto connects except UDP on Q ground control, so that it'll only connect once it receives a heartbeat message from Mavlink through UDP. So you'll see, once this is deployed and ready, I actually have to go and run my plant. My plant's the one that's going to take the UDP message and tell Q ground control, hey, I have a Pixhawk in the loop. You can go and decide on your mission, take a takeoff, change the parameters, just like you would from QGC. And the Pixhawk's actually connected to your computer, and you're running this through Simulink. So I'm going to quickly create a mission here and go to my plan, upload that mission, and then go into plan and confirm it. As soon as I confirm that mission, Pixhawk will start running. You can go into Simulink and then start looking at the states of your plant. So this is the final step where you've done it in Simulink, you've tested the code, now you deployed the code directly onto the Pixhawk. Of course, it's still hardware in the loop. The Pixhawk's not moving anywhere, so you have to simulate the sensors, and we do that in our in Simulink itself. All right, so this is sort of the start of, we can say, like your flight, right? You haven't done any autonomous algorithms yet. You're just making sure that the control scheme on your drone is good. It's stabilized flight. It's not kind of wonky doing that when you're trying to get to places. So I'll let Mihir now talk a little bit about doing some scenario simulation. Come on. Go ahead.
Thanks, Ronal. All right, so Ronal showed us how you can deploy on PX4 with hardware in the loop simulation. But what if we want to look at, as we talked a little bit in the beginning, a photorealistic simulation of how the drone is flying in, say, a city block? And that's where we bring in the Unreal integration. And that's more photorealistic, but to begin with, we also have cuboid world or more basic primitive shape simulation. So that's what I'll show you quickly. And here is something like what it looks like when we imagine it, but how it looks like in the MATLAB and Simulink world is something like this. So the left bottom image is a cuboid environment that we can build in MATLAB, and that's something really simple to build, and you can fly a drone in there and have simulated sensors that are scanning these boxes and generating an environment for you. Or testing your algorithm, obstacle avoidance, or path planning. On the right, it's the Unreal simulation that pops up from the Simulink Unreal integration. And to build these simpler scenarios that, like a city block with primitive shapes, we actually have a UAV scenario designer app. So really interactive app where you can quickly build cuboid-style environments. You can have drag and drop elements to bring in buildings and other environment items in the scenario canvas. Or you can also have more complex environments like the one you see here that you can actually bring in by importing different external files like DTED or OpenStreetMap files or even STL files. So this is something that we have recently introduced to help you build these scenarios in a more interactive way. And then you can obviously also use the sensor models like LiDAR and also execute a path through this environment as we saw in this video. And then Simulink is where we integrate all these different components. So Ronal showed the other pieces like the ground control station, the flight controls and plant model. Those are the two ends in this block diagram. But what we are looking at right now is the environment and sensor model block here. So inside this block is where we can add these scenarios and sensor models, and that's how it fits in this workflow. And then the output of that sensor model is what we use for the obstacle avoidance and autonomy algorithms here. And that's where a lot of our customers find the value. So to have their algorithms being tested, they really want to visualize it and have these environments and scenarios work for them instead of having to fly the drone to test these or tune these algorithms. So as I mentioned, inside these blocks, we have different sensor models like the GPS, IMU, INS. So that's what these blocks are showing here. We have built-in blocks for all these different sensor models. And then this is a simple city scene block in the cuboid world. And you can see we have a simulated LiDAR here that's scanning these different blocks. And then the other option that this model provides is you can toggle between these two. So once you're satisfied with your algorithms in the cuboid world, you can switch to a more photorealistic Unreal environment. And we provide different blocks to just drag and drop and to generate this Unreal environment. So you can have like a built-in, you can use a pre-built city scene block, which is hosted inside this block here, the 3D scene configuration. You can have your UAV model fly in this city scene by bringing in a UAV vehicle model block here. And then there are 2 other blocks for simulated sensors. And the interesting thing is you can also simulate weather effects here. So you can have rain, you can have sun and other lighting effects in your Unreal environment. And that's something that you can test your algorithms with. So with that, I would like to hand it over back to Ronal and let him show that how this scenario simulation piece fits in with the hardware in the loop workflow.
Awesome. So just to come over. Not everyone needs a photorealistic scene, which is why we provided the cuboid. Mihir mentioned you can do LiDAR, INS, GPS in the cuboid scene itself. But if you want something photorealistic, you want to do something like, recognize a person or track a car, that's, you really need some good photorealistic scenes. That's where Unreal integration comes through. So I want to continue from where I left off. We already talked about model in the loop, software in the hardware in the loop. While this is happening, we can also have another connection to Unreal. The really nice part is you don't need to have Unreal installed. It launches directly from Simulink. If you have a project that you have open, you can connect it with that. If you deploy that project as as an executable or export it as an executable, then someone else can launch it directly from Simulink. That's actually what we do here. We don't have Unreal Engine or Unreal Engine open or a project open. It actually is just an executable that's just routed from one of the Simulink blocks. Again, this is an example that's available for you to try, so you should be able to go to the website, click on this example. You can get a trial if you want, and you can run this on your own computer. You don't need anything else installed. Right, so let's take a closer look at this. So this is how it's going to run all together. Again, we have the plant actually running in Simulink. We have an Unreal scene in which we've deployed a quadcopter. You can see on the top right that we get a really nice, you get multiple frames of, from the camera sensor that's on the drone itself. Of course, we're giving the same mission. We're uploading it from QGC. Once this is over, I'll actually show you how this all connects together. It's very similar to what we saw already. You'll notice that the plant model is still the same. The only added model is the one on the bottom. So the flight controller stays exactly the same. The actual plant model stays exactly the same. But the new piece here is our scenario simulation model. So before we can do that, we'll actually go and build our Pixhawk. So this is still running in hardware in the loop. So just like we did before, we're going to reboot it and make sure that we flash our new flight controller onto the Pixhawk. Next, let's actually look at the scenario simulation piece. So the plant actually acts as a bridge here, where it's able to communicate with the Pixhawk using UDP, and we also send information to another model using UDP, right? So we have the plant reading from what the Pixhawk is pushing out, and we have messages that the state of the actual plant is also being sent to Unreal. With all those three put together, this is the actual piece that I was just talking about. You can see I have two UDP connections open. One talks directly to the Pixhawk, and the other one talks to my scenario simulation. The plant model stays the same. We've already looked at this. Nothing changes, so you don't have to make any additional modifications. The way you started it first stays exactly the same. You just add this new third piece that actually launches Unreal for you. So it's actually all in Simulink. You don't have to have anything. This is a scene that we provide with UAV Toolbox, so you have access to this really cool city scene if you want to fly it around here. If you have custom scenes of yourself, you can pull that in too. Great. So that was like the larger workflow. I'll let Mihir take it back and close off our presentation.
Thank you, Ronal. So yeah, hopefully we're able to show you a workflow that relates somewhere in your applications, and we'll be happy to help you if there are something that pops up as a question. But to close off, I would like to highlight the importance of simulation again. So it really helps with ensuring safety, and we don't want to crash those drones that really expensive and risky. So testing flight behavior in simulation is a good idea, and that's where our tools come in. And the good part is what Ronald showed today was how you can build on top of that basic model. You can start with a really simple simulation, but the same model can be extended towards the deployment phase. And you don't have to redo things. And finally, you can deploy your algorithms directly from the models that you made in Simulink. And why MATLAB and Simulink? I showed you in the beginning, the V model. We really support from modeling and simulation to code generation to verification and validation. So really want to help you throughout the process. And as we talked about UAV Toolbox, this is something that we are here for. We launched this product in 2020, and we have more features other than the simulation piece with PX4, something like flight log analysis. If you're working with ULog files or telemetry data, you can use an interactive tool to bring in your data and analyze it. There are algorithms like SLAM, path planning that are available with the tools that you can use for autonomy. And we have reference applications that you can use out of the box to get started with. So really a lot of things to play around with, and we'll be happy to help you where your application takes us. So some resources here. We also would like to ask you, this is a call to action for us, to give some of your feedback. So we have really quick 3 questions on this QR code. So we really want to end it with these questions. If you can give us like just a minute, scan the QR code. It will also help us to know what you are working with, where are the pain points that we can help or improve our tools. And while you're doing this, we will also like to open up for questions. So feel free to ask any questions here if you see anything interesting through the slides.
Yeah, I know we covered a lot of content. So any questions on how you build the models or how the communication works? Sure.
The blind model that you have, that is basically your model of the drone, right?
Yeah.
How much customizable it is? Because, I mean, when we talk about autonomy, you are offloading a lot of, I mean, in most of autonomous cases, I would say I would go for a model-based control rather than just PID 2.0. And in those kind of cases, if I want to make that controller more robust, then I would need wind gust testing and
Right.
things like that. So is all that stuff like configurable in the plant model? Or?
It is. So we actually give you a large fidelity, right? You can start with a very simple model, and even the simple fixed wing or quad model lets you add environment effects. So wind, north, down, up, gravity is, it's 9.8 that we put it at, but you can change it if you want to, if you're going to fly in the moon or something. But yeah, you do get to add weather effects or wind as environment effects.
And how about the drone model itself, like mass inertia, what props are used, and how much thrust is produced?
Right. So this model was, so that's actually using our aerospace block set. I don't know if you've heard of that before, but we start with a point mass, right? A 6-off point mass, and then you build out the forces and the inertias, and you say what the mass is. So it's all physics-based, right? You build out your entire model based on what you think is representative of your platform. Yeah, so it's completely customizable. Thanks for the question. Anything else? Yeah.
For the environment, like the one that you had in the city, right? That's like from your library?
Right. It's an environment that we provide from UAV Toolbox itself. So it's something for you to get started with. You can also just use one that, maybe open up Unreal project and build one yourself and then use that.
Well,
But
so normally, how would people go about creating a new environment for their own research or their own environment?
you would start with an Unreal project. So Unreal Engine lets you open up a project and then start putting meshes or buildings. A lot of assets are available for free. So you can start building in a world, with the assets that are available. You can also buy these. People actually build Unreal environments and then they sell it to you if you want it. So if you find something that's really nice, you can buy it and then link it to Simulink. So you just point it to the path of where you put it, and then that environment will open up. So you can build it entirely yourself using Unreal Engine.
You can customize both the environment as well as your drone model, like the platform. So both of them can be more, you can bring in meshes in Unreal Editor. So for that, you have to download Unreal Editor separately. Just for visualization using the pre-built city scene block and the pre-built platforms, you don't need to do anything. It's right in the Simulink, comes with the tool. But if you want to do this customization, you need Unreal Editor installed. And inside that, you can bring in meshes for the scene as well as the platform, and then you can customize everything. And we actually have documentation along with our tools to follow along for this customization process as well.
Right, we have an example that shows you how to create a custom environment. We'll be happy to share that with you.
That's cool. So for like the custom environment, like besides wind and all those kind of like earth things, right?
Mm-hmm.
Is there functionality to be able to simulate things like more like on the communication side,
like networks?
Wi-Fi or like those kind of like communications outages or whatever, like.
Right. I don't know if Unreal Engine has any kind of wave propagation in it. We actually have another tool called Mapping Toolbox, an RF Toolbox, that'll do that for you. So we can take the position of the drone from Unreal Engine, and you can state where your antennas are and see what kind of coverage you're getting. So you can actually do that in Simulink. You don't need it as a part of the visualization, but it can be another model that does that for you. Yeah. Thanks for the questions. Yeah. Anything else? Yeah, please.
It seems like the blocks actually subscribe directly to like your projects, and then you can experiment with the code. How does this work with like the rest of the Pixhawk? Do you always work on like these stable releases, or do you actually have a workflow that?
Right, really good question. So it makes it really hard for us to keep up with the newest release that PX4 pushes out, right? Because we have to look at what's been changed because we're deploying to the architecture, so we need to know what the architecture looks like. Right now we're on 1.12.3, so we're sitting on the most stable one. And before that we took 1.10.2. So we phase out how quickly we jump into newer releases. But I have some customers that I work with that like just fork off the master, and they're able to do SITL and software in the loop and hardware in the loop with MATLAB. So if you want to work with newer releases, you would have to have some idea of the architecture and how PX4 works. You have to know how threads are called and how to you have to build that interface a little yourself. The good thing is if you deploy it from 1.12.3, you will see the module that's been pushed out, and you can kind of take a look at that module and rebuild it for yourself. So the source files are available. You can just move that over to your newer repo and build it there. But out of the box, we support 1.12.3 right now. Yeah. Awesome. Thanks for the question. So I highly recommend. Actually, I really hope that you do scan this QR code. There's 2 or 3 questions that we would really like, feedback on. And once you do answer that, you get all the slides and the resources that we sent, that we just presented to you. Anything else?
All right.
Yeah.
Thank you, everyone.
Thank you so much.